And we're back. We're working on 5.5, part 2 with the substitution method, so working on integration. So with example 5, you can see that we have the sine of 6x. So if you kind of take a close look at it, the 6x definitely looks like the inner function or the inside function. So what I'm going to do is I'm going to say u is equal to 6x. And if I'm going to change to a u substitution, I'm changing to u's, then dx's have to change. So I have du is equal to 6 dx. Notice I don't have a 6 in the integrand. I only have just the sine of 6x. So in this case, I'm going to have to change over. I'm going to say that I'm going to divide both sides by 6. Recall that I did this in the last video. I'm going to divide both sides of the equation by 6, and I get du divided by 6 is equal to dx. So 6's cancel there. So with that, then, we're going to integrate. We're going to do the switch over here. So I get the integral of sine u, and it'll be times the du over 6. I'm going to pull the 1/6 out, and we have the integral of sine u du. So our integrand is just sine u. So remember that you have to do the think cycle sometimes. If I want the antiderivative of sine u, whatever it is, the derivative of that, here I'm finding the antiderivative. So the derivative of that thing is going to be a positive sign. So I hope you can see that this is going to have to be negative cosine x. Because if I take the derivative of negative cosine, I'm going to get a positive sign. So we get the antiderivative of sine u is negative cosine u plus c then for the general antiderivative or the indefinite integral. And then we're going to take the u back because the u, recall, was 6x. We're going to go back to x's, and we have 1/6. We're bringing negative out front, and we have cosine 6x plus c. So we now know that the integral of sine 6x, and I think that's my time is about up right now, is then equal to negative 1/6 cosine 6x plus c. Okay, I'm going to put them on hold for just a minute and finish one more example. Find the antiderivative. So hopefully you can see in this problem that we have an inside and an outside function. The inside function is, of course, tan. So I'm going to say let u equal tan x, and then du is equal to secant squared x dx. And I look and I have the whole enchilada, if you will. So I've got secant x tan x there. So I'm going to just do a one-to-one substitution, and I get then the integral of the square root of u du, and I'm going to rewrite. So we have the integral of u to the 1/2 du, which gives me then, let's integrate, we've got u to the 3/2 power over 3/2 power plus c. So let's move over here this way. So then we can really finish this. We'll say the integral of the square root of tan x secant squared x dx is then equal to, I'm going to put the 2/3, remember you multiply by the reciprocal, so you divide by 3/2, you multiply then by 2/3. I'm going to put in brackets, and u is tan x, so I'm going to put tan x to the 3/2 power plus c to get our final answer. So with integration in each of these parts, we're often looking at what we consider to be an inside function or an inner function, and then its derivative, if we pick that to be our u, its derivative must be somewhere else in the integrand. So be very cautious about how you're picking, but if it gets more complicated, the general rule in mathematics is if what you're doing gets super complicated, you probably picked the wrong u, or you've probably headed down the wrong track. We have one more example on this video, and we're going to do example 7, where we find the antiderivative, where we're using a u substitution, but it's not just when we reverse the chain rule. So we're going to use the same method for the inside. This isn't just a composition of functions, but we do have the inner and outer, where most of you would probably say u is equal to x plus 2, and du is equal to dx, right? The derivative of the left, du is equal to dx. So we begin to substitute, and the first thing we notice is that we've got this square root of u, and we've got a du, but what do we do about the x? So we clearly have a problem here, and we've got to find our way through this. So the one thing that I do is I come back over here and I look at the u. So if u is equal to x plus 2, what is x equal to? X is equal to u minus 2. Well, maybe that'll help us resolve this. So let's go back to the drawing board. The poor little guy, he looks all worried. But maybe we can fix this. So now we have, let's go blue. So we have u minus 2 in for x. And then we have the square root of u du. So let's see what this gives us. But remember, we're going to write square root of u a little differently. We're going to write it as a power, so that's u to the 1/2 du. And then I recall that I can distribute the power, so I've got that. So in the mechanics of this, we're going, okay, this is u to the 3/2 minus 2u to the 1/2 du. Now we're in u's. Remember, we're eventually going to remember that u is equal to x plus 2, and then we're going to integrate. So we get the following. We have u to the 5/2 over 5/2 minus 2u to the 3/2 over 3/2 plus c. And this should just take one more minute. We have 2/5 u to the 5/2 minus, this is going to be 4/3 u to the 3/2 plus c. And remember that u in this problem was equal to x plus 2. So we have the integral of x times the square root of x plus 2 dx is then equal to 2/5. Remember, u is equal to x plus 2. So we get 2/5. 2/5 times x plus 2 to the 5/2 power minus 4/3 and x plus 2 to the 3/2 power plus the arbitrary constant c for our final answer. So you see, it works very much like undoing the chain rule, but in this case, we used U-substitution with just a composition of functions that was not just chain rule or undoing the chain rule. So we have our answer. I have the next video, then we'll deal with the definite integral with U-substitution. So I'm going to sign off for now. Have a good night, and I'll talk to you soon. See you tomorrow.